Hello and welcome to section 4.2, which is called the unit circle. We're going to be looking at coordinates on the unit circle and how to deal with triangles around the unit circle today, and using Pythagorean theorem a little bit. So when we're dealing with the unit circle, just a reminder that you have a radius equal to 1. We're going to list the coordinates of the 4 points on the unit circle that lie on the x-axis. So our 4 points would be here, 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 and here. So just a reminder that this radius here is 1. Okay. So if I look at the coordinate that is on the positive x-axis, if our radius is 1 from the center out to that point, our x-coordinate should be 1, and on the y-axis, our y-coordinate should be 0. Now, if I go upwards to the positive y-axis, again, our radius is 1, but this time this would have a y-coordinate of 1. And since we are on the y-axis, our x-coordinate should be 0. I can continue to the negative x-axis. Our radius is 1, but we are headed in the negative direction. This means x would be negative 1 on the x-axis. Y would be 0. On our last point on the negative y-axis, on the y-axis, x should be 0. We are on the negative y-axis, so our y-coordinate should be negative. And again, we would have traveled a distance of 1. Now, the next portion is telling us let P, x comma y, be a point on the unit circle above. So I'm going to put a point on my unit circle. This is going to be point P, and this has coordinates x comma y. Using Pythagorean theorem, we want to find out what the equation of the unit circle must be. So first, I know that this has a radius of 1. And if I draw myself in a little triangle here, let me just remove my r equals 1 that we wrote before. It's kind of in the way, if it will let me. Nope, okay. So if I draw myself in a little triangle here, we know that the point x comma y means I traveled right by a distance of x and up by a distance of y. We know that this has a radius of 1. Okay. And this is a right triangle. So by Pythagorean theorem, I know that x squared plus y squared must equal 1 squared. Or x squared plus y squared equals 1. This is considered the equation of this circle, or the equation of the unit circle. And this will work for any radius. I could change that 1 on my hypotenuse to any number, and I would still have x squared plus y squared equals my hypotenuse squared. So this means that any circle has an equation x squared plus y squared equals r squared for a circle of radius r. Okay. So I could ask you to find the equation. Oh no, some technical difficulties. Let's see if I can fix this before we get going. Let's open this up again. All right, let's try this again. Okay, so we said x squared plus y squared was equal to 1 squared. So for us, that was x squared plus y squared equals 1. And x squared plus y squared equals r squared for any circle with radius r. Okay, if you need to see that diagram again, if you scroll back in the video, it will show you that again. It's just on my end that my Word document has collapsed. So you can keep going, no problem. So this means that I could ask you to find the equation for any circle as long as you know the radius. So the next question says determine the equation of a circle with center at the origin and a radius of 2. Okay. If our radius is 2, we're going to have x squared plus y squared equals 2 squared, or x squared plus y squared equals 4. So we are going to try and determine the coordinates for all these points on the unit circle that satisfy the given conditions. So the unit circle automatically tells us that r is 1. This means that we know x squared plus y squared equals 1 because 1 squared is 1. Okay. So if our x coordinate is 2 over 3, that would be on the positive x-axis. So if we're at positive 2 over 3, we're out here somewhere. Now, if we're on the edge of the circle, that means that our point could be here or here. We have 2 possible points that we might have. Now, if our x-coordinate is 2 over 3, we know our hypotenuse is 1. We just don't know our y-coordinate for our points. And we can use our Pythagorean theorem to find that. So we know that x squared plus y squared equals 1. Our x-coordinate is 2 over 3, so I would have 2 over 3 squared plus y squared equals 1. And now I can use Pythagorean theorem to find y. And I should get 2 different answers for y because I have 2 possible points, P1 and P2. So I would have a positive y and a negative y. They should have the same amplitude, just different signs. So I get 4 over 9 plus y squared equals 1. Y squared is 1 minus 4 over 9, which means y squared is 5 over 9. This means y is plus or minus the square root of 5 over 9, or plus or minus the square root of 5 over 3, because the square root of 9 is 3. Okay. Now this means that I have my positive and negative points. So my possible points are 2 over 3, comma, root 5 over 3. That would be P1. And 2 over 3, comma, negative root 5 over 3 would be my P2. So the positive point in that first quadrant would be with the positive y value. The point in the fourth quadrant with the negative y value would be my P2. Now the second one gives us a little more information. It tells me my y-coordinate is negative, so automatically I know I'm going down this direction here. Okay. But it tells me I'm in quadrant 3, so I know I'm not in this quadrant here. I have to be over here somewhere. So my point would be somewhere on this section of the circle. Okay. Now, again, I know that I have a hypotenuse here of 1. If I make my triangle, a reminder that when you're drawing triangles in quadrant system, we should always be basing it off of the x-axis. So I should not be drawing a triangle over here ever. I should always be drawing my triangle using the x-axis as one of the arms of the triangle. Okay. Now I know that this coordinate here is negative 1 over root 2, but I don't know the x coordinate. Okay. So I'm just going to call this P3 because we already used the other 2 points. So I know that P3 is going to be some x value, comma, negative 1 over root 2. So again, I know x squared plus y squared equals 1. I don't know x, so I'm still going to have x squared. I have negative 1 over root 2 squared as my y. If I square that, I get 1 over 2 equals 1. That means x squared is equal to 1 minus 1/2, which equals 1/2. This means that x is equal to plus or minus root 1/2, or plus or minus 1 over root 2. Now, because I'm only in quadrant 3, I'm not actually going to use both of these numbers. I only have one possible point. If I only have one point, I can only have one x value. So I'm going to keep the negative x. So this means my point is going to be negative 1 over root 2, comma, negative 1 over root 2. So we have a notation here that is p with brackets and a theta equals x comma y. This means the point associated with angle theta is equal to x comma y. So for example, if theta equals negative pi, then p theta is equal to negative 1, 0, or p of negative pi is equal to negative 1, 0. And we saw this on the front page. If we look at our quadrant system, the angle negative pi means we're traveling in the clockwise direction by pi radians, which leaves us on the negative x-axis. And we know for a unit circle, the point on the negative x-axis was negative 1, 0. The point associated with negative pi radians is negative 1, 0. Now, this point would also be associated with other angles, such as pi or 3 pi or 5 pi, but that's not what we were asked about here. Now, there are a couple special triangles that you dealt with that you will need to be comfortable with as you go through this chapter. These are triangles that you should know from Math 11. If you don't have them memorized, you should do so. And we also are going to be looking at these in terms of radians. So 45 degrees, we talked about already in a previous lesson, was pi over 4 radians. 30 degrees was pi over 6 radians. 60 degrees was pi over 3 radians. So we have two special triangles. The 1, 1, root 2 triangle, which was our 45-degree triangle, and our 30, 60, 90 triangle. And the side lengths of that were 1, 2, and root 3. Now, the problem is if we draw any of these triangles in our unit circle, these don't work because any triangle I draw in my unit circle should have a hypotenuse of 1. So if I want to, I can adjust these by basically scaling them down so that they do have a hypotenuse of 1. So if I look at the left-hand triangle, if I wanted this to have a hypotenuse of 1, I would need to divide my current hypotenuse by itself. I would need to divide by root 2. Now, if I do that, I would have to divide all the sides by root 2, or my triangle will no longer be the same triangle. So that means that if I'm dealing with my unit circle, this side and this side would be 1 over root 2. So basically, I'm scaling this triangle down by dividing everything by root 2. I can do a similar thing with my other triangle. My hypotenuse is 2, so if I divide everything by 2, I would have new side lengths of 1/2, root 3 over 2, and 1 if we are dealing with a unit circle. So we're going to use these to help us with our next question. So on a diagram of the unit circle, we are being asked to show all of the integral multiples of pi over 3 from 0 to 2 pi. So this means we're going to go around the circle once, okay? And we're going to look at all the intervals of pi over 3, which is the same as 60 degrees. So our first interval would be 60 degrees, okay, which we know is in quadrant 1. Now in quadrant 1, if I look at my special triangles here, I know that I have my lovely little triangle looking like this. my 60 degrees, or my pi over 3, remember, goes in that bottom left corner. That would be our reference angle. Okay. I know that my hypotenuse should be 1. And if I match it up with the triangles I have above, I know that my pi over 3 always is across from my root 3. And because I'm scaled to be for a unit circle, I'm not using root 3, I'm using root 3 over 2 here on my side length. So my pi over 3 should be across from my root 3, or in this case, my root 3 over 2. Now that means my last side length should be the 1 over 2 from that special triangle. That means the point on the edge, point P of pi over 3, is equal to x, which is 1 over 2, comma y, root 3 over 2. So P pi over 3 is equal to 1 over 2, comma, root 3 over 2. Now my next iteration would be 2 pi over 3, or 120 degrees, which is in quadrant 2. Now remember that 2 pi over 3, or the 120 degrees, is measuring from your positive x-axis up and around to that terminal arm. So the problem is if we're not comfortable with reference angles, it's going to be hard to label this triangle. Now, if this is 120 degrees, then we know our angle in this corner here should be 60 degrees. Or if this is 2 pi over 3, my reference angle in the corner should be pi over 3. Okay. Now, again, I know my hypotenuse is 1. I know across from the pi over 3 should be our root 3. And in this case, root 3 over 2, since we're dealing with our unit circle. And that means the bottom measurement should be 1 over 2 from our special triangles. Now the problem is that this is a negative x-axis, so this should actually be negative 1 over 2. So our point here for 2 pi over 3, my x-coordinate is negative 1 over 2, and my y-coordinate is root 3 over 2. Our next iteration would be 3 pi over 3, or pi. Now again, on a unit circle, we know that if we are on the negative x-axis, our coordinates, so we could write this as 3 pi over 3, or p of pi. Our coordinates are negative 1, comma 0. Our y-coordinate is 0, we're on the x-axis, and our x-coordinate is negative 1. Now next we would have 4 pi over 3, which is going to be in the bottom quadrant here. Okay, so p of 4 pi over 3 is next. So we have 1 pi over 3 is blue, 2 pi over 3 is black, 3 pi over 3 is red. Now we're at 4 pi over 3, purple. Now again, my reference angle in the corner at the top should be a pi over 3. Okay, it's kind of hard to write it here because of my negative 1 over 2 that's in black, but that negative 1 over 2 still applies. That distance along the bottom of my purple triangle is still negative 1 over 2. My dashed line, my vertical distance, should be root 3 over 2, because we're using the same special triangle that we've used the previous two. We're just in a different quadrant. Okay? My reference angle in the corner there, that I've kind of made a mess of here, my reference angle here, let's just zoom in a little, make it easier to see, is still pi over 3. So across from the pi over 3, we have our root 3, or in this case, since we are on a unit circle, root 3 over 2. My x-axis is my side length of 1, or because we are on a unit circle, 1 over 2. And My x and my y should both be negative because of the quadrant that I'm in. My x and y's are all negative in this quadrant. So my point is negative 1 over 2, comma, negative root 3 over 2. Now next I would have p of 5 pi over 3, which means I'm going to be traveling into my fourth quadrant. Again, my reference angle should be pi over 3. Across from the pi over 3 should be my root 3. In this case, it's root 3 over 2 since I'm dealing with my unit circle. And my y should be negative because all my y's in this quadrant are negative. My x is positive 1/2 because my x's in this quadrant are positive. And we could go one more. Oh, no, we're not going to go one more because one more would be 6 pi over 3, which is 2 pi, but my domain says I am not including 2 pi. So I'm going to actually stop there. It did tell me, however, to include 0. So I should have, I didn't do, along my positive x-axis here, I should have p of 0. Now on my positive x-axis, remember that my x-coordinate will be 1, my y-coordinate 0, because I'm on the unit circle. Okay. So my special triangle I'm using in all of these is the same. It's the 30, 60, 90, the 1, 2, root 3 triangle from above on the right, and I'm just moving it around. My reference angle in all of these, that lower corner angle that's attached to the origin, is pi over 3. Which means my opposite side to that is root 3 over 2, my adjacent side is 1 over 2, and my hypotenuse is 1. So we've actually already done part B. What are my coordinates? We've already got a list here, so we've actually already done that. Again, remember with these videos, feel free to pause, rewind, or scroll back. You can watch it at a faster speed, slower speed, skip forward, or rewatch as many times as you need. Make sure you're getting really comfortable with using these radians here.